Hello everyone, this is Eren Şahin. I'm a sales engineer from liNear. Today's topic is BIM workflows with liNear solutions on Revit. I will show you our BIM workflows such as early planning, void planning, collusion check and parameter manager, manufacturer libraries and so on. Building information modeling is a construction sector initiative with global implications, tied closely into the increasing use of IT in construction. BIM is in essence a digital model of a building or structure that is data enriched. It defines spaces, systems, products and materials together with their properties, addresses how those components interrelate physically and technically, and looks ahead to future maintenance needs. It encompasses the entire life cycle of an asset from initial concept design to demolition or refurbishment and can be applied equally at new build stage or when an asset is required which has already been constructed. Integrated design means that even in the early design phases, all parties involved work together on the concept of the building. With our tools for design, dimensioning and placement of equipment rooms and supply pipeline corridors, you have the possibility to optimize the installation of the design's building services in collaboration with other trades already in very early design phases. The resulting initial effort is more than compensated in subsequent design stage by reduced friction points and shortened revision planning. With the tools you can determine realistic requirement for the equipment rooms and coordinate this with other parties involved, for example the architect in the very early design phases. This enables active conflict avoidance instead of costly changes having to be made in the course of confliction resolution in the later design processes. The space required by the equipment rooms of the individual trades can be either determined quickly and easily in accordance with the rules of EDI 2050 with just a few specifications or specified based on experience. The equipment rooms can then be placed in the model as provision for space, and the space requirements can be compared with the available space in a conceptual architectural model. The export of the equipment rooms by means of IFC enables quick and easy coordination with the architect. The pipes of the individual trades run from the equipment rooms to the consumers along pipeline corridors. With the pipeline corridor function, these can be constructed very easily. Subsequently, the cross sections are defined and assigned to the individual pipeline corridor sections. Adjust dimensions is a quick and easy way to adapt the space requirements of the pipeline corridors to the assigned cross sections. Once the pipeline corridor concept has been coordinated with all parties involved using IFC, the pipelines can be generated automatically and used as the basis for further design phases. Now let's see how to do this on a real project. Here we have a Revit model. The total area of our project is 2,210 meters square. In early planning, our responsibility is to estimate values for technical rooms and pipeline corridors. At first, we activate the pipeline corridor workflow and then go to the Analysis tab. And then we start the Equipment Rooms command. Here, we click on this calculator and select New Administration Type Building. As you see, there are different types of buildings right here. And then we add the value for the gross space area, and this is this value, and then we give the building height. You can also select if there's a sprinkler system, ventilation system, or cooling ceiling. You can consider this dialog as a control panel. There is no restrictions, but here you can compare these area values that you planned with minimum and maximum area. These minimum and maximum area values come from the standard VDI 2050. This standard is determined to define the aspect of BIM. And also liNear and their new research and development part, liNear Building Labs, is working closely together with several institutions at the RWTH Aachen, one of the few excellence universities in Germany, and together they move new processes and define these workflows. After we apply these values, they will copy to here. When we add our equipment rooms, their dimensions will be appear in here, and we can easily compare these values with the standards. And now we will create a view. In order to do this, we go to the Project tab. In the Project tab, liNear asks us 3 questions. First of it, where do we create this view? The answer is when we select the building part and the story. The second question is what? So we select what discipline do we want to work on. We will work on the pipeline corridor discipline. And the third question is how. So we choose what type of view do we want to create. If it's a 3D plan, floor plan, or a ceiling plan, or another type of view. And then we select the floor plan and click on Create View. When we say Create View, it will appear on this list. So we already have this ground floor pipeline corridors view. And then we open it. After we create the view, we will start the command to do the configuration for equipment rooms. Here, we can easily select the discipline and the dimensions of this component. When we activate the command, liNear will automatically create the cubicle component that represents the equipment rooms for the selected discipline. And now we create these components for heating, let's say for cooling, and for electric, right here, and we can create this configuration. After we create these components, we can easily change their dimensions as we wish. When we check them out in a 3D view, we can see those components are created and placed right here. Let's change the view. Hide the building. As you see, the components are here. Now let's continue with the final form of the project. And here we have the final form of our project. Let's hide the architecture again. As you see, there are lots of technical rooms are placed. When we click on them, we check linear properties, and this is for heating, and this is for ventilation, and these are for electric, and this one is for potable water, and all configuration has been made. And now we can export this project as an IFC file. Save it as a sample architecture. Let's save it. And when we create an early plan, and if you want to share this with the architect, there are 2 ways to do this. These methods are Open BIM and Closed BIM. For Closed BIM, we share our project as Revit project or via BIM 360 with other parties and get comments. For Open BIM, we create these components as provision for spaces and export this as an IFC file. And when we check out our IFC file in Autodesk Naviswork, as you see, all provisions are exported to here, and we can see its parameters. And now we will see how to place pipeline corridors. First, let's go to the floor plan. As you see in our project, these pipeline corridors are already placed. Right here, we have our floor plan. In order to place these pipeline corridors, we go to the construction, and then we activate this command. As you see, we haven't given any values for width and height. We can just simply construct this network without extra information, because this is the point for early planning. As you see, it's very simple. You can just draw these corridors like you're drawing a duct, a normal duct. And these routes are like equipment rooms, and they are there to represent provisions for spaces for pipeline corridors. After the construction is complete, we will determine the cross-section, and for this we go to this command, and then we click this new cross-section command, and here we will do the configuration. When we click on this plus sign, it automatically placed a pipe. What is this pipe? You can see the discipline and the system class right here. If you want to change its diameter or alignment, you can change it from here. If you want to add another pipe, for example, you can simply click on this plus sign and then this one again, and you can say this one is a supply water. If you want to divide the selected cell, you can easily use this command and give a quantity. And when you say OK, as you see, there's another gap in here. When you click on the plus sign, you can add another type of pipe or duct from here. You can just select the discipline and you can select the profile. As you see, there's a rectangular duct. You can give its dimensions. You can easily create this too. For this, you can also do the same thing. If you want to change its place, you can select the duct. You can use this command and it will move it to left. Or you can select this one. You can move that to the right side. For this sample, we already have some configurations. As you see, there are two different cross sections. The first one includes two types of ducts, supply and exhaust air ducts. And this one is a wastewater pipe. And this one is for electric, and these are for heating, supply and return water pipes. And the other one only includes two types of ducts and an electric cable tray. After you do this configuration, and you click on Assign Cross Section and select a pipe and press Enter, it will just ask you to which cross section do you want to apply for this pipeline corridor. And then when you select a pipeline corridor component in liNear properties, you can see the configuration that has been made by us for cross sections, and you see their dimensions, the types of the pipes, and then when you select another pipeline corridor, let's select this one. As you see, this one has a different configuration, and you can see all dimensions and system classes and disciplines for that pipes and ducts. And then when you go back to the analysis tab and select the equipment rooms, you can see the planned area and minimum and maximum area, and you can compare these values. For this sample, as you see, all planned areas are designed in between minimum and maximum values. Let's take an example when the architect was not so accurate in the building modeling. liNear checks the model in its correctness and gives us the notes that, for example, the walls are overlapping. as an MEP engineer normally doesn't have the access to the architectural model due to the respective roles and responsibility which defines by BIM manager. He needs to transfer this information to the architect in order for him to correct the model. Here, the BCF format comes into play. Another example where the BCF formats can be effectively used within BIM processes is slot planning. Slots or openings are recesses or holes in walls and ceilings to lead pipes or ducts through them. In order to guarantee the static integrity of a building and to manage efficiency, routing, coordination between the building disciplines and the technical trades is essential when planning slots and openings. liNear CAD offers you interfaces for communication and coordination of void proposals. With our void planning discipline, collisions can be checked and void proposals for solving them can be placed in a single step. The void proposals are initially provisions for voids. They are exported using the open standards BCF and IFC and can be communicated to the responsible person. Those responsible for buildings can import the proposals with the free liNear voids add-in and classify them with accept, which means voids are created in a model, or reject. The classified proposals are saved and sent back to the technical trades. It allows the responsible person to open BCF files containing void proposals and classify the proposals as either rejected or accepted. Void proposals can be displayed individually or in multiple selection in the architectural model. No license for liNear solutions is required to classify the void proposals. As you see in this project, we have different kinds of pipes and ducts, such as ventilation ducts and flexible pipes right here, and wastewater pipes, and so on. Also, we have different types of walls, such as flat walls and round walls. And also, we have different kinds of collusions, like this. And now let's go to the void planning construction tab. And here, we have manual provisions command. Here, we can select the type of the provision and we can give its dimensions. And when we activate the command and select a wall, as you see, the slot will be created and we can place it manually where we want to place. And when we do the selection, the slot will be created, as you see, like this. We also have a semi-automatic function. In order to do this, we activate the size by component selection command, and then we activate the provisions command, select the wall and the component, and when we confirm our selection, as you see, the slot will be created with the semi-automatic selection. And of course, in this command, we can also give a lateral distance right here. This semi-automatic selection command will create the void proposal based on the size of the component. When we use this command in this case, for example, we select this wall and these two ducts, and then when we press enter, it may create a joint slot for both of the pipes. Of course, we can change it to two different voids from manual provision command. In the automatic provision command, we can specify design settings. We can set lateral distances for rectangular and round provisions. And also we can do a selection for automatically joined slots. We can set a minimum distance for this case. And now let's delete this one and do an automatic provision. We activate the command and select everything, press enter, and now we select all pipes and ducts, and and press on enter, as you see, all void proposals are automatically created. And also with this command, you can join two void proposals manually. And with the labeling command, you can label all void proposals that we created. And now we will export our void proposals as a BCF file. In order to do this, we activate the export command and we do all selections, and let's this out, and we say, and yes, we can change the name of the output. We can say HVAC, void HVAC, and we click on OK. And the BCF file is being created. In case the architect doesn't have a linear software to open this BCF file, they can download a free add-in to see all these topics. In order to do this, you can just simply click on this link and download the linear void manager for free. Now I opened our architectural project in Revit, and there is no linear, as you see. And here we go to add-ins and open linear void manager. With this add-in, you can only see all proposals that is created by linear. And in here, we will open our BCF file. When we open it, as you see, all of these void proposals are listed right here with their stories and dimensions, and their status are all proposals. You can accept or reject all proposals from here. You go to this tab and you select the void proposal and click on show. As you see, it will show us exactly where it is on the floor plan. And after you see it, you can accept it and export again for further processes. Let's say we accept all of them in one time. And for example, let's reject one of them and give a comment about it. Open here and we click on details, and we can write our comment. Let's say, please move this one 500 millimeters to the left. And then we can save our new BCF file. We can just say new, save it, and then we open our project again, and in here we click on the coordinate command and then select our new BCF file and we say OK. As you see, all accepted void proposals colors are turned to green, and then we have one red proposal and this one is rejected. And then let's go to the topics and let's link these topics with the new BCF file. Say OK. As you see, all of our issues are accepted here, except this one is rejected. And we see the comment right here, these initials, and it says please move this one to the 500 millimeters to the left, and we can do our adjustments on the project in order to complete our void plan. The appropriate quality and right quantity of data which is stored in the model on different project stages is one of the challenges which comes along with the BIM implementation. For example, does the planner really need on the early stage the 3D model of boiler with the highest resolution and all possible data saved in it? Usually the answer is no. In the beginning, the boiler can look like a simple box with respective operational space specified around it. And only later on, when the MEP systems are completely constructed and calculated, it comes to the detailed visualization of the equipment and installations. Here, the manufacturer libraries come in charge. In cooperation with the industry, liNear offers its customers extensive CAD libraries. This allows you to design your project using the actual manufacturer components, thereby greatly increasing the benefit of our material and order list. The different CAD libraries are available in 2D and 3D. All data have been verified by the manufacturers and therefore guarantee a safe and effective design. A one product family is automatically created as part of Revit integration. As you see in the liNear CAD browser, there are different manufacturers. For example, if you want to insert a component or replace the ones in the project, you can select a manufacturer and select in its catalog values. For example, let's select this one. You have a pump right here, a Grundfos pump. You can see its technical data right here, all its documents. And here you can select which CAD platform do you want to use. And when you select one of them, you can place it, replace the one on the project, or replace all of these pumps in the project. You can select the level of detail right here. You can say it's a simplified view like this, or a detailed view like this. And with this way, you can use exactly the same component that you use in the installation, and you can use real values for your calculations. Right now I will also show you our liNear Parameter Manager. liNear Parameter Manager allows you to assign calculated or written liNear parameters to your own shared parameters in a mapping table. To open this, you go to the liNear in ribbon, and then you open the Parameter Manager. As you see in here, there are a lot of liNear parameters with their explanations, and you can easily select the discipline and then filter these rows. When you select a discipline, you can see some liNear parameters like here in a bold font, and some parameters that are taken from the architecture, and whichever you place first will be activated in the project, and this data will be written into the component. And you always have the option to choose between liNear data or the data that comes from any kind of component. One of the most important topics for BIM is collusion check. Since each construction project contains different content from many different disciplines, this problem is very common and they are generally getting solved in application phase. BIM softwares are designed to foresee these issues in modeling phase and letting you know before application. In this manner, liNear has expanded the possibilities of the Revit building collusion checker massively. With this command, everything is possible, from a targeted search for collusions between two system types to the collusion of all components, even with the link model. Each collusions will be listed in liNear control board issues and tasks tab, and there you can easily see and solve them. You can also set whether collusions with provisions for voids should be taken into account, or define an area around pipes, ducts and cable roads in which no objects may be located. In this way, you can ensure free space for installations, fixings and assembly. Let's make a collusion check on this project. We go to the liNear menu and open the collusion check. If we go to settings, we can see that we can check our collusions with the provisions of spaces for ducts and pipes, and also the cable trays. As I said before, we can define an area around the duct, the pipe or a cable tray, and we can check the collusions in between these areas. For this model, we check mechanical and piping, and if we go to details, on mechanical we can see there are all types of ducts and modules and mechanical equipment, and under piping we can see all flex pipes and pipe fittings, insulations and pipes. And when we say OK, as you see, the collusion check have found 13 cases, and it says collision between duct fittings and ducts and between pipes and mechanical equipment. And when you click, it will show you the location that this collision occurs. And to solve this problem, you can just move the duct, or you can give a duct offset or a pipe offset. And this is the option for the engineer who works in this project. And here we can see these topics just like we did in the slot planning. And we can still write comments and add views to tell what exactly the problem is. The construction design workflow is getting used to edit pipe and duct networks to create the design for the construction site. Before we start to use this workflow, we have to make sure that the project is finished for all disciplines. With the functions of this discipline, you can cut ducts to producible section lengths, display pipes in available delivery lengths, insert flanges in pipe networks, add fixations to pipes and ducts, and insert them item numbers. In this workflow, we can first select the delivery length for pipes and ducts. We can easily do this with this command right here in the Construction Design tab. This is the section and delivery length command. We will determine the length and minimum length of sections and activate the command. After we select our pipes, press enter, it will be divided to the sections. Also with this command you can position flanges at pipe ends, at pipe accessories, as a pipe separations, whereby the dimensions of the flanges is of course automatically adjusted to the nominal diameter of the pipe. And for fixations we use this command. To place fixations we go to the 3D view. The fixing elements can be placed individually inline, suspended from ceilings, suspended on floors, or mounted on the walls. The inline placement mode allows the placement with a given distance between elements. If the distribute symmetrically function is selected, the elements are distributed equally around the axis point of the selected area. Now we will place our fixations to our project. First, we go to this front view and we select consoles. Then when we activate the command, it asks us the starting point. Select the starting point, the end point for our consoles. And as you see, they are automatically placed. And now we select the pipe clamp, and then we activate the place on console option. We select the clamp with the rubber insert, and the type will be automatically determined by liNear. And when we activate the command, it asks us to select the pipes. We select our pipes, enter, and it asks us to select the bracket, and we select our consoles, and we click on enter. As you see, all fixations have been automatically placed to hold our pipes. And we have come to the end of this webinar. Today I demonstrated how to use BIM workflows for MEP engineers with liNear solutions on Revit. If you have any opinions on our webinar, or if you have any suggestions for topics that we should cover in our next webinars, please let us know. If you need more information about this subject or liNear, you can reach me via esa@linear.de. If you want to watch this or previous webinars again, you can follow our liNear YouTube page. Thank you very much for your participation.